One evening, you're watching a documentary and witness the surreal glow of alien-like creatures drifting in the blackness of the ocean's depths. It's hard not to be awestruck. Our planet's largest habitat lies beneath miles of water, almost as foreign to us as the surface of Mars. Despite centuries of seafaring, we still know shockingly little about what roams these hidden realms or the landscapes that shape them. That's where artificial intelligence is stepping in, driving a new era of deep-sea exploration. Welcome to AI and Underwater Exploration, Mapping the Ocean's Mysteries, where autonomous subs, machine learning algorithms, and advanced sensors work together to reveal secrets we've barely begun to grasp. If the ocean's unknown frontiers make your heart race, consider subscribing. Your support helps us investigate how technology merges with Earth's most mysterious domain. For years, underwater research was limited by the physical challenges of extreme pressure, frigid temperatures, and near-total darkness once you venture beyond the sunlit zone. Traditional oceanography ships can drop remotely operated vehicles, ROVs, or submersibles, but those missions are expensive and time-consuming. Now, AI-driven marine robots, some fully autonomous, are changing the calculus. Picture a fleet of torpedo-shaped drones silently cruising the ocean depths, scanning with sonar, collecting water samples, and snapping high-resolution images. Instead of returning daily for instructions, these machines use built-in intelligence to decide where to go next, what interesting features to investigate, and how to optimize battery power. They're essentially robotic explorers, responding to the ocean's cues in real time. One of the most immediate applications is in mapping the ocean floor, which remains a bigger mystery than the surface of Mars. Machine learning algorithms help interpret sonar readings, transforming echoes into detailed 3D terrain maps. This might mean detecting submarine canyons, ridges, or even volcanic formations that had never been charted. These datasets can aid navigation, identify potential undersea hazards, vital for submarine cables or shipping lanes, and guide scientists seeking active hydrothermal vents, a key research target because vents support unique ecosystems with life forms that might resemble those on other planetary bodies. Gathering such data used to demand countless hours of manual interpretation. Now, AI can process it as the drones swim, generating near-instant topographic images that are fed back to onshore labs or nearby research vessels. Another frontier for AI in the oceans involves detecting signs of life, especially in extreme environments like hydrothermal vents or deep trenches. The temperature gradient at a vent can swing wildly, near boiling water on one side, near freezing on the other. Unique bacteria and complex organisms thrive there, tolerating conditions that would kill most surface life. Scientists hypothesize these organisms hold clues to the origins of life on Earth, and maybe even life elsewhere in our solar system. By equipping underwater vehicles with AI-driven spectrometers and chemical sensors, researchers can identify chemical signatures, like spikes in hydrogen sulfide or other compounds that hint at biological activity. The drone might catch a whiff of an unusual chemical plume and, using its onboard intelligence, choose to linger in the area, capturing high-resolution video to confirm whether a new species or ecosystem is present. These discoveries don't just advance basic science, they could also guide us toward preserving marine ecosystems under increasing threat from climate change, overfishing, and pollution. AI-based drones monitor coral reef health, mapping bleached or diseased corals across vast areas and offering real-time updates on how warming waters affect them. In polluted regions, they can sample water quality at multiple depths, analyzing contaminants on the spot. By comparing baseline data with newly collected samples, machine learning models can detect subtle deteriorations in reef systems that might signal impending ecological collapse. This early warning capacity is crucial for local governments and conservation groups trying to act before entire habitats degrade beyond recovery. Some programs have even tested AI-driven reef cleaning robots that, while still experimental, can remove invasive species like crown-of-thorns starfish. Data from these efforts feed back into an AI ecosystem that refines how best to manage and restore fragile underwater realms. The story doesn't stop at conservation. Industries eye the seafloor for potential resources, whether it's rare earth elements for electronics or polymetallic nodules laden with cobalt and nickel. A controversial discussion revolves around deep-sea mining. Is it the solution to resource bottlenecks or a reckless threat to pristine ecosystems? AI could play an outsized role in mapping mineral-rich zones with surgical precision, potentially reducing the ecological footprint if mining becomes inevitable. Imagine a sub-scanning for nodules, identifying where the impact of harvesting them might be minimal, and planning extraction routes that avoid sensitive habitats. Critics worry that efficiency might spur more aggressive exploitation, so transparency in how we gather and use these data becomes key. Yet, some obstacles remain. Communication underwater is notoriously difficult, as radio signals don't travel well through dense water. Drones often rely on acoustic modems, which are limited in bandwidth. This means the AI systems have to be fairly autonomous, making decisions without real-time guidance from surface labs. If a drone stumbles upon a new species or potential hazard, it must adapt or investigate on its own, uploading data only when it resurfaces or returns within acoustic range of a research ship. Designing robust autonomy is no small feat, especially when dealing with currents, unpredictable seafloor terrain, or the possibility of mechanical failures in deep, high-pressure environments. Another challenge is energy. Running advanced sensors and AI computations demands power, which is in short supply on submersibles. Some research groups are experimenting with fuel cells or pioneering ways to recharge from thermal differences, like tapping the gradient between colder surrounding water and hydrothermal vent heat. The dream is a perpetual underwater drone that roams indefinitely, fueled by the environment it's exploring. That future might be decades away, but each incremental innovation extends mission duration and depth, letting the AI stay out longer and gather more data. Of course, an even bigger challenge looms over all these applications: the question of ethical boundaries. If we map fragile habitats, do we risk revealing them to exploitative interests? Could AI inadvertently guide destructive fishing fleets or deep-sea mining corporations to the last unspoiled corners of the planet? Balancing open scientific knowledge with responsible custodianship is no trivial matter. Some argue for data sovereignty, where local and indigenous communities own the intelligence about their adjacent marine zones. Others suggest universal guidelines for how deep-sea data can be shared, ensuring that knowledge doesn't accelerate environmental harm. AI itself is neutral. It follows its programming. The human decisions surrounding that programming matter immensely for the ocean's fate. Yet, for all these concerns, the overarching sentiment is hope. The more we understand about the deep ocean, the more we might respect its wonders. We might uncover bizarre life forms that shed light on the resilience of biology, or identify carbon sinks essential in mitigating climate change. Maybe we develop advanced prosthetics or medicines inspired by deep-sea organisms. By mapping the ocean floor with unprecedented clarity, we could improve tsunami and earthquake predictions, as many seismic faults lie below the sea. Imagine an AI spotting a microquake and relaying warnings hours earlier than any current system can manage, potentially saving coastal lives. In each of these scenarios, technology serves a protective, enlightening role. If these possibilities ignite your imagination, subscribing to our channel or following updates from marine research organizations is a great way to keep up with the latest. The pace of innovation is breathtaking. What was once science fiction, underwater drones guided by machine intelligence, now patrols the ocean's darkest corners. We're witnessing the dawn of an era where the watery part of Earth, long overlooked, becomes a domain of meticulous exploration. The AI revolution that reshaped astronomy, medical imaging, and social media is diving deeper than ever, promising to rewrite our understanding of life on this planet. In the end, AI in underwater exploration is more than just fancy gadgets. It's a reaffirmation that Earth still holds vast, uncharted territory. The oceans are our largest frontier, teeming with mysteries ranging from ancient shipwrecks to hydrothermal vent ecosystems that might mirror alien worlds. As these AI explorers swim further and deeper, data accumulates at an unprecedented scale. Yet it's up to us to interpret it wisely, to use it for preserving and appreciating the ocean's richness, rather than viewing it as another resource pool ripe for exploitation. And that, in many ways, is the real test: whether we can match AI's technical brilliance with an equally advanced ethic of stewardship.